day, everybody, and welcome to our webinar on turning unstructured data into business action, exploring the role of generative AI. I'm Denis Gagné from Trizatech, and I'm joined by Tom de Beauvois from Advanced Component Research for this presentation webinar. Slides will be made available, and the recording will be made available after this presentation. And we will try to answer questions at the end. I say try because we have an awful lot of material, and we're trying to squeeze that in 30 minutes. So hope you enjoy the material. Feel free to put questions in the comment thread. We'll be monitoring this, and we'll be trying to address these as we go forward. So, okay, hot topic these days, AI from just about every point of view and everybody. So we want to talk about our journey, basically, in the last few years in doing some work on this market. So our interest is around intelligent digital assistants. So we've been working on an intelligent digital assistant architecture for a few years now. We're focusing on an architecture that will be meant to support knowledge worker. And in particular, our architecture needs the ability to consume natural language communication because of the nature of the work that the knowledge worker does, where their work tends to be a lot of collaboration, a lot of interaction, a lot of swivel chair type of integration. And so that relies a lot on communication. So we're currently developing our third generation of this IDA architecture, and we want to share with you some of our findings in that work. So while empowering knowledge worker, what we're looking in terms of benefits are listed here. So we want to really look at personalized support, efficiency improvement, tailor recommendation is very, very important. And user needs understanding is really a big focus of what we've been doing on the natural language understanding aspect of all this. And we'll be discussing this today. Hopefully, we won't get too technical and too deep into things for you, but feel free to contact us if you need any more information. So the goals of this intelligent digital assistant architecture is to support seamless natural language communication and very much more so enhance context awareness. Because when you're having this multi-party communication, collaboration going on around work, context is the key. Context is everything. And we've mentioned that in other presentations that we've done, Tom and I. So we want also some proactive assistance. We want this collaboration to be very robust, advanced personalization, and certainly not least, but certainly there is an ethical and trustworthy behavior from that agent or that architecture. So we favor a assistant or co-pilot approach, whatever you want to name it, because we're really looking in this collaborative augmented intelligence market. So our interest is really with this augmented intelligence. So it's not necessarily the artificial intelligence that we're interested in pushing here, but more this augmented intelligence. So our idea is to have the benefit of human ingenuity combined with the machine intelligence while maintaining the human oversight throughout all this interaction and work. To do so, we have been leveraging a neurosymbolic architecture. For those of you that may not know what a neurosymbolic architecture is, it's basically combining rule-based and more structured type of artificial intelligence approach with more unstructured type of artificial intelligence approach that we call sub-symbolic, or basically where the symbolic aspect is manipulating concepts at a higher level of abstraction, where the neurologic or neural network approach or the subsymbolic approach is more focused on processing information through some form of cognition or some form of recognition, I should say. And the main purpose or main goal here in using a neurosymbolic artificial intelligence architecture is to enable explainability. So we want to make sure that we maintain explainability of what those different systems are doing, how they're coming to those conclusions. We want to do that bridge between perception and cognition, so this interaction between the two aspects. And we want to also reduce the reliance on data sets. If you're doing a purely neural network approach or a purely predictive model or generative type of AI, you need quite a large data set to actually achieve good performance from these models. As most people know, the ChatGPT and Claude and all these different LLMs are trained on trillions and trillions of data points that is beyond the access of us or any other organizations. So another thing that we're leveraging in this architecture is a theory that is called a speech act. And basically, this approach or this framework, speech act, is the idea of when you were having collaboration or communication, I should say, the language carry more than the word. So there is always kind of a second level communication within the interaction. And the speech act approach is to look at these communication and try to detect intent. For example, like if I say, book a flight to New York, there's an intent of me giving you a directive that I want you to perform that task to book the flight. In terms of context awareness, sometimes context is required or implicit in the communication, but very, very important. So for example, if I say, can you complete this? In a conversation regarding a report or anything, it's important to understand that this is a polite request to do a task of completing what was in the context of the conversation. And then there's the action mapping associated with them, where if I say send an email to John about this meeting, again, all these other aspects of intent and context are there, but we have to realize that these are actual action that needs to take place. And we all human do that very implicitly and directly. It's processed in our brain. But for a machine, those nuance and higher level type of understanding are harder and needs to be processed with more technology and more quote unquote intelligence. So
I would just add to that slide is a large amount of this discussion takes place over email. So we need to be able, if we're going to engage with these speech acts, we also need to engage with the email side of this. So which again kind of adds another layer of complexity to leveraging these speech acts.
yes. So with the advent of generative AI, we're seeing a lot of technology being developed, a lot of progress being done very, very quickly. And so given that we started this work prior or aligned with this advent of generative AI, we have to look at how these enhanced language capability from generative AI, large language model in particular, of that family of AI, impact what we do and how this will bring value. So now this advent of AI has brought a lot of attention in the market. And while there's a lot of benefits to it, like enhanced capability and innovation and efficiency that are gained. We have to make sure that we communicate on these topics without, bringing all the magic into this, or there's a lot of misunderstanding in the market because of all those terms. It's certainly overhyped at this point. So we're trying to be very pragmatic in what we're presenting to you here. We're going to things that are concrete results and that are making advancements and usage within the business context.
I would just briefly add that a lot of the negative hype it ends up with a sort of a baby in the bathwater situation in that what we're presenting today are things that generative AI can very easily and responsibly do. So it's even though it's overused, this is kind of like the low-hanging fruit of the large language models that are simple to understand what they do and utilize in the processes we're going to describe.
So the advent of generative AI basically gave us an opportunity to rebalance our mix of symbolic and non-symbolic AI. And this rebalancing basically comes from all the benefits that we have. So where before we had to do a lot of things within the symbolic approach, now we have the benefits of using the large language model to help us do things. So this rebalance had all kinds of different effects within our architecture. I'm going to go through a series of these elements very quickly because we have a demo that we want to do, and I want to make sure that we give time for Tom to do this demo and explain this demo. So I'll walk through these elements a little bit faster, if you will allow me. So some of the rebalancing came on many lower level language elements. So it's becoming a little bit more technical here in the sense. So we're looking at the capabilities that we revised and rebalanced are around name entity recognition, data structuring, intent detection, text generation, and topic identification. And I'm going to zoom by on these topics here. But the slides are going to be available. The recording is going to be available, so you can go back and consult the slides at your leisure after. So in terms of name entity recognition, it's this idea of being able to extract entities and understand what these entities are. So for example, in this sentence, Apple launched the iPhone 15 in Cupertino, California on September 12, 2023. The name entity recognition is the ability to recognize that here, in this particular context, Apple is not the fruit, but Apple is the organization, and that iPhone 15 is actually a product, etc., etc. Previous approach that we were using had a more brittle and structured, where we had to use very structured approach. Now LLMs allow us to do that in a more context-aware and much more tighter recognition without having to provide too many elements. The next topic is data structuring, where going from a free text, we can actually generate a data structure from a programming point of view, so that this data structure here, we're showing an example using JSON to help us move forward. And then again, I'll skip through those. You can go and look at the justification on your own. Topic identification is this idea of being able to extract from a free text what the topics are at a higher level of abstraction, often referred to as semantic lifting. We've been doing presentation in the past about semantic lifting, so that there's an understanding here that this is about a contact manager, some calendaring, and some email messaging to give us a better context. And then there's intent detection, where we're understanding the user's goal behind the words. So can you help me schedule a meeting and send a summary to my team? Doing this with rule-based or structured symbolic approach was very hard to do because there was confusion about situation where there's multiple intent, where here, recognizing with large language model, recognizing that this is both about scheduling and summarizing is a lot easier and more efficient to do. And then text generation, I guess I don't have to talk too much about that one, given that's probably what most people know large language model for, their capability of being able to just instruct them shortly and get a text generated, which was before was harder, and we were stuck in using templates and all kinds of different approach there. This gives us a much more dynamic environment. So I'm now going to pass the floor to Tom so he can talk to us about streamlining the knowledge worker processes.
So much of this discussion stems from an analysis we did of a knowledge worker process related to closing real estate deals, right? So in a real estate contract, the interactions with the numerous players are very complex. A lot of approval, requests for different deliverables, interactions with government agencies are going on within the context of closing a sale of a real estate process. So, and these processes, including things like product design or even financial product design and so forth, involve a lot of discussions between people, meetings, interactions, and so forth. So they're very resistant to traditional business process modeling types of situations. So, but we still don't want to abandon trying to create a structure or streamlining these knowledge worker processes. So we've really basically been able to utilize these different prompt types in order to extract the most important milestones out of the different phases of the process itself. And what we can do with this type of approach is to really simplify many of the most burdensome tasks that the knowledge worker has with respect to formatting and creating the proper communication, and then understanding what their the role or the steps in their processes are occurring, and then being able actually to improve their productivity. So the next slide. Unless you have something more to say.
Yeah, I was just going to say that fundamentally, a lot of the work that was behind the motivation of all this was some years back. We look at how can we get an intelligent agent to support human in operationalizing contracts. So when you have a contract, whatever the type of contract, this contract can be a policy, can be whatever, but we want this agent to be able to understand the contract as the context of all the collaboration that's going on.
Exactly. So let's go ahead and we'll start the demo. And in this demonstration, we're going to talk about a basic interaction between a manager who wants to hire someone and the accountable manager who needs to approve that hire, right? And so he's going to ask the intelligent digital assistant to do this hiring, and you can see that the name, the dates, and the starting salary are all included in this request. And at this point, right, the knowledge worker copilot or the intelligent digital assistant will start a process, right? They're going to create a label in the workspace for the manager and put contact and calendar events, and then compose a message and send that message to Angie, who's the accountable manager. Would you please approve that? So there's the contact, here's the calendar event. On there, we've done, again, the entity extraction and the context awareness. And the January 5 is the good till date. That's when the employee offer is done. You can see that the contacts are added to that. So, and let's go ahead and we can see we have a folder here for Barbara, the new hire, right? So at the next step, the accountable manager, I just created this email and sent it to Angie, right? So Angie sees that I have a new hire request, right? And she's going to reply back and accept this new hire request. That gets back to that intent recognition. So I say, yeah, I would approve this, but she might have a question, she might reject it, and so forth. There are a number of different things that we need to account for in managing the process itself. So now we're back at Tom, right? And Tom, the IDA is going to create a draft of the employee offer letter to send to Barb, who's the new hire, right? And he'll make any changes or adjustments or just send that. And we've made a decision of when to send one, when to draft one, right? And it's going to go back to Barb. So next we'll look at Barb's desktop in a moment. And again, IDA will be monitoring these communications going back. Barb might have questions of, how much vacation do I get, or what is my work location, or this, or make some type of adjustment. So, here I am as Barb, right? And I'm going to again accept the employee offer. That gets back to the natural language understanding of the intent of Barb with respect to that communication, and any entity extractions done. And then finally, we'll ask IDA, I'm in here as Tom, and I'm going to say ask IDA what the status of Barb's new hire is. And we can do other things like send Barb a message like, hey, Barb, how's that employee offer going, and so forth. And so there's a range of commands that can take place. So that in a contract, you're going to have many of these, and they're going to be highly interrelated. So the benefit of the Knowledge Worker Copilot is that we can manage all of the little details with respect to that. So let's go back. This is not an actual business process. This is a description of how we are managing prompts, right? So you want to maybe not necessarily the same data store, but all of our prompts are essentially in different formats in a single data store, right? So when we make the call to the large language model, right, we're actually making that through a process similar to what you see here, where we pull the prompt out, we combine it with the free text, and then we execute the prompt. And that prompt might bring back some type of result, like I characterize accept, reject, question, as in the case of intent, or some type of data structure that would be utilized to create a calendar event or a contact or interact with some process. Next slide. So how do we minimize hallucinations? The most effective way I would say of doing that is to use simple and explicit prompts, right? So the prompts that we write are easy to read, easy to understand. We keep them simple, right? First, in the next step, you describe in a preamble, not in a discussion. Like if you're describing some employee new hire process, you will act as if you're talking to an intelligent person about what your objective with respect to that free text evaluation is, right? And that goes a long way in terms of, especially in terms of intent evaluation and entity extraction, to making certain that it will always perform example. And then next, we provide examples You can provide short examples. Usually most of my prompts, and we have over 70 of them, have only 3 or 4 examples, right? And then again, you can take that prompt and the examples that are provided and ask the large language model to evaluate the risks associated with it. And they've gotten increasingly better at explaining based on the structure of what you're providing me, here are the risks, here's how you could improve the performance and the evaluation of the problem. So, and then finally, which is something we hardly ever do, is don't make any inferences with your prompts. Be very explicit, right? Be very careful about using some type of, for instance, categorization. So in the example below, we had the apples have shipped. Don't say fruit. That's a fruit shipment. That's a bit simplistic, but you don't. If you're going to use some type of inferencing, make certain that you provide good examples in your demos to make certain that the large language model understands the type of inferencing that you're using. At some level, we're always doing a bit of inferencing in terms of entity extraction. But if you're like adding translations on layers and layers on top of that, it's not really going to give you a result that you could use in a knowledge worker process. So go ahead, Denise.
Oh, no, I was just going to say that's a lot of material that we're trying to provide you in a very short time. So the basic takeaway, and we're almost on time there, so we won't have time really to address the question, but feel free to send them through email or get to us. So the takeaway from this particular presentation is that using generative AI, we were able to have better information and extract context in a simpler way than was previously available. In particular, we rebalance our symbolic and non-symbolic AI capabilities on notions of topic identification, name entity recognition, data structuring, sentiment analysis, and text generation. We also are focusing on this speech act treatment or processing to really get a sense so that the artificial agent can actually know what the actions are. So out of the general communication comes an action to be done, and then the agent reacts. So rather than being a very prescriptive environment, this is a very dynamic, evolutive environment where things are happening quickly. So we have at least time for one question. We're almost on time. So we have a question
for the first one from Winston.
So can you enlarge the integration between the BPMN process model as created in Trisotech and the AI assistant? So fundamentally, what's going on behind the scene of all this technology, we're using both process, case, and decision management, so using BPMN, CMMN, and DMN to provide the scaffolding and the context management of everything. And non-symbolic recognition is feeding and recognizing that this is a request to a response to a report, let's say. And then that will trigger that particular process or that particular case. And then that case will scaffold the artificial agent so that the agent will always do the same thing in a deterministic way when he's doing these particular actions. So we're mixing both the symbolic and the non-symbolic by scaffolding using BPMN, CMMN, and DMN as the background deterministic approach to things.
The only thing I would just, we're out of time, but rapidly add is that the process, BPMN, DMN allows you to manage many different APIs and understand when you need to use them and integrate with all of the services very easily. So it simplifies a lot of the complexities of doing this. And so what you saw in terms of interacting with email and so forth had over 50 different smaller processes that did what Denis described. So, okay.
So thank you very much for your attention. We're already on time. We have some more questions in the thread. We'll make sure to try to address them via email. Again, feel free to contact us. Thank you for your time and attention. We hope this was useful and provided you some insight on this technology.
Thank you, guys. Have a great day.